Hey guys, how's it going? This video is going to be a little bit scuffed, but yeah, I'm just going to give it a shot. So what I wanted to do was show how you could make a packet parser that doesn't need SCAPY in Python. It doesn't need anything. It just needs Python. This will only work on Linux. You could do it on Windows, but to be honest, I don't care. Everything I do is on Linux, so it's all I really know how to do. Anyways, what I have right here is some code that I just pre-wrote that I use actually in some of my projects, kind of modified it a little bit. So I'm going to go over it and kind of explain what it's doing. Really what I hope you guys do is download the code, screw around with it. I'm going to show you how it works, what everything means, but you screwing around with it is going to be where all of the actual learning is going to come from, not me talking about it. Okay. So there's two main parts of this, right? Part one is you have to be able to accept some type of packet data into Python, so you could even do whatever with it, right? So Python has a way that you could do that with the built-in socket library. What we're going to do here is, because it's going to be just like a sniffer, listener, or whatever, we don't really care what type of protocol it is. We just want to see it completely raw. So we're going to use a raw socket, and we're going to bind to the interface directly. That's going to pretty much give us all kinds of weird stuff that you're going to have to make sense of if you want to do anything with it. Because it's going to be every protocol that ever gets hit on the interface, right? So I have a little bit of code here that I wrote just to kind of do that. The first little line here just creates the socket, and then I bind it on the interface, which I'm using Ethernet 0. That's what my system is. You're going to have to change that if yours is different. And then once that's done, I just do a loop over a socket receive method call for 2000 bytes. This is a blocking call, so if you use this in any other application, you can't do anything while this is just waiting for something to come in. You would have to either use threads or async IO or epoll or something like that if you wanted to do multiple sockets at the same time. Don't really want to get into that. This is just to show how you would do it kind of in one little, application kind of thing. Hey, just pop this up real quick and see what's going on. So there's that piece, right? The next piece is how you actually want to store the packet or represent the packet in Python. I prefer to use a class for this. It's interesting because using a class in Python is a little bit slower than, functions and doing things locally, but we're going to need to reference this stuff somehow. So there's a couple things that you could do to make it quicker that I'm not doing here. One of them would be if you wanted to implement slots, which is essentially, if I do slots, it would just be like this. Oops. And then I would have to define all of the local attributes here that are going to be used, and then I'll cut like 20% off the lookups for that. I would have to do it for every single one. It's not really a big deal for the demonstration. Just know that slots are a thing. I might go over them in another video or something, but I don't want to make it too confusing. So like I said, I do this in a class. So every instance of this class represents one packet. What I'm going to do is I'm going to get the data from the socket. I'm going to insert it into the class here with a call, initialize it, right? Put the data in, and then I'm just going to call parse. And when I call parse is going to kind of do some logic for me here. Whoops. Where it's like, hey, what protocol is this? So we're looking at IP first. We want to know what protocol it is. Now, every single protocol, Ethernet, IP, TCP, UDP, they all have like a standard. So realistically, what you're going to want to do is get familiar with those, because that's very important in dealing with this. You could see here, I'm doing some slices of the data. That's because I know what the protocols are supposed to be size-wise, and I'm picking the correct, spot for where it is. So if you look at any graphic or chart or whatever, that will explain that for you. Where it gets a little bit crazy is that all of them can be a different size depending. So usually what's going to happen is they're going to have a header length field inside of it, and that tells you how long the header is, and then you could properly calculate that dynamically. And so hey, it goes to this point, and then all the rest is the next bit or whatever. I have all that done already, so like I said, I don't want to make it too crazy. I just want to show you how to actually do it. You could mess around with whatever and figure that all out and go deeper into it with this code. So what I'm going to do here is I'm just going to run this. I'm going to show you basically what it does, and it's super easy, really. I'm not really sure if I feel like a lot of people think that this is a difficult thing to do, and especially doing it manually yourself. The hardest part, I would say, is just understanding what protocols do what and what each field means, right? So I'm going to run this code, and I have it in a loop, right? So it's just going to keep going, and I've already done it, but I'm just going to do this, and now it's just sitting there, and it's looping over the socket, right? Receive. And I just have some random chatter on my network that's pretty stupid. I'm not really sure. It's like some Wi-Fi device being all pissed off at something. It's been there forever, but that's why it just keeps, you get a broadcast. If I do any other type of connection, it will be here as well. So to show you that, what I'm going to do is I'm going to have Wireshark going here. I'm just going to do it on DNS UDP port 53. And then that's going to be, my code is going to be checking everything. And then I'm going to do a DNS query to Google, right? So we just saw it there. And let's switch over to here. And if I scroll up somewhere, we should be able to find that. That was a big one. What is all that? Oh, we got some TLS stuff going on. Web traffic. Okay. Lots of datas. Oh, well, here's one, I guess, that is a DNS packet, but it's not the one we were looking for, but we could use it. So I don't know, my browser was doing some stuff probably in the background. I have Brave browser, so it was doing like a lookup for whatever. You saw some like 443 stuff. That, I guess it couldn't have been at a better time, because you're basically seeing just all random crap coming in. And what I'm not doing is I'm not looking at the particular or the higher level protocol, right? I'm just going up to TCP or UDP. Once I hit that point, I just stop. So all I'm doing is printing the payload. From here, you would want to go, if you want to go deeper, like in quote deep packet inspection, and you want to go into the payload, it's like, okay, well, this is port 53. We know that's DNS, so we can go over this data and follow the DNS protocol to know what is what. And it does have an explicit protocol that you could go and parse this out. You would be doing it in the same way that I do it. For the other ones, you would just have to follow that protocol, right? So maybe that's something that you could use to, take the next step in like understanding this. Maybe make the DNS portion parsed out. So other than that, I want to show you kind of, or explain a little bit more so what the code does in a little bit more Python way, right? So what we're trying to do here is we're trying to take gibberish that you saw, this gibberish, and we're trying to make it look like this. Realistically, when you think about it, if you're trying to deal with this stuff, you probably don't want it to look human readable most of the time, because why? Why do you care? You want your application to do something. It doesn't need it to be human readable. You just want it to be identifiable to the system in whatever way. Well, it's all bytes and integers and all kinds of stuff, that it's perfectly fine. Anyway, what I do is two things. The first thing is for IP addresses, I just use the built-in library IPv4 address, which will give me an IPv4 address object where I can take raw bytes, it'll make an object of it, and then I could print it out as a string or do other types of things with it. I could repack it back to bytes if I wanted to. So it's kind of just a really nifty way to deal with IP addresses without having to manually parse it as a string. It's like a Python object now. And that's just part of the standard library also. So you should get familiar with that one. It's really nice. Keep in mind though, every function call you do and every, like whatever, like module or something that you might use to make it easier for you is going to be making it slower. We don't want that. So you want to keep it as bare bones as possible here. This is all low level stuff. You don't want to be using all kinds of other garbage because it's going to take too long. You want it to be snappy. We don't want some slow parsers. So the other one is struct. Struct is in Python is either done with a function or a class like this. And essentially what it does is it does like what you would expect it to do for taking like a really low level like data and making it higher level. So I make a struct of a specific like, set. I'm going, hey, HL, that's like short, long, byte, like the integer types, sizes or whatever. And I'm like predefining that in a struct, and then it's gonna pack or unpack that to be like the raw bytes into just regular integers that I could use. And so for the two headers, TCP and UDP, I'm gonna use that to give me the integers back. And so that one's pretty straightforward, like making that human readable is easy. I'm just gonna unpack it with the struct. Now this is the compiled form of it. So a lot of people, what they'll do is they'll do the like the lowercase one, which is just the function. They have to actually set the size, attribute, values, whatever, every time they call it, and then they have to call unpack or whatever also. So what I'm doing here as like an optimization, and I'm doing that in multiple cases here, is I am doing the compiled version ahead of time, and then I'm also assigning the method that I'm going to be using to this. So now I don't have to call two things. I just go right to the method call. So it's going to do what I want directly. And so anytime I'm doing packet parsing, I'm going to do everything in my power to ensure that we're doing it as snappy as possible, given that this is Python. And it could be very, very fast. I have like a whole bunch of code doing this in real time, real fast on like pretty poor hardware even, and it keeps up with like Nmap and all kinds of other crazy stuff. Like don't even know that Python is doing it, to be honest. Partially because you can offload a lot of stuff. A lot of the lower level mechanisms of Python are just executed in C anyway. Now there was one other thing I wanted to mention related to that performance stuff, and this isn't really having to do with parsing, but it's about like kind of like a weird little optimization you can make. So I want you guys to keep in mind that what I had mentioned before about the speed, and then also know that there's a lot that can be done to kind of work around that. So for example, here, I am locally assigning data, right, from the object. Well, I could just reference it directly, right? But look at how many times I'm referencing this, would be referencing this object. 1, 2, 3, 4, 5. 5 times 6. 6 times, right? So that's a lot of lookups. If I set it to a local variable first, I don't have to do an instance lookup. I just have the local variable lookup. It's super fast. I'm gonna show you what I mean. Not that one, here. So this is what I use to like optimize my code just straight up without having to run profilers or anything. This doesn't lie. All it's saying is how fast it takes to read a certain type of object and how fast it takes to write a certain type of object. Specifically, the top two, right? So local, non-local, global, built-ins, instance variables. Here's the slots I was talking about. So if you can see here, reading an instance variable is 25 units of speed. It doesn't matter what it is, just 25 units, right? And this is 20. So that's 20% performance boost just by using slots. But look at this. If I read a local, it's 3.9. So now what you have to realize though is that you are taking time to write that. So I have to write a local. It's only 4 though, right? 4.3. And I still had to read it once. So I still read it once here, which would be slots for me if I did it with slots. And then I write it. And then all the rest of the reads are 4. So there's like 4-ish, 4 to 5-ish lookups that I prevented after calculating the kind of initial one, right? So that's like 20 minus the 4, so that's 16 times 4, however many units that is, that's how much we saved just in that one little piece. Just in here. We're doing that for every single one. So you can see how, you know, a lot of people talk about how Python is slow, but it's because they're stacking all these really kind of unoptimized operations on top of each other over and over and over again, to the point where you're just doing a whole bunch of like work that doesn't even need to be there. So doing tricks like this will make Python super quick. We won't even notice it. Mainly because this is all IO bound anyway, right? We're waiting for packets to come in. We can only process if we get a packet. How long will it take to get a packet? If we send a packet, we have to wait for a response. How long does it take? It takes me, you know, 1/10 of a millisecond to process. It takes them 50 milliseconds to get it back. Who's waiting on who? Python, or, you know, are they waiting on Python? You know what I mean? Anyway, so I think that's pretty much it for what I wanted to talk about. Like I said, sorry, it's pretty scuffed. I'm on some medicine at the moment. Don't really quite have a clear goal of what I was trying to get out. I just wanted to kind of go over it and everything. What I'm going to do is I'm going to upload this code in my repo that you can go and grab. And technically, this code could just be imported. And then all you need to do is call listen forever from one of your applications or whatever, sending in the interface, and it'll just kind of start parsing for you in your own code. It's not going to return or do anything like that, right? But you could easily adapt this to return back the fully parsed packet. Like, you know, instead of right here, it just parses it or whatever, and then it prints it. It could just return it back to you. Like here, return it back to your application. And now you kind of just extended whatever you were doing with this kind of already done for you. But try to go, you know, like I said, farther and maybe do DNS is really easy to get going with. The protocol isn't very complicated. It's UDP, so you don't have to worry about connections. And it's you know, very well documented, very old, and the fields don't really have a whole lot of meaning. What more so is just being able to identify what the records are for DNS. So yeah, let me know if you have any questions. I usually stream on Twitch. Schedule's going to be changing here, but if you want to come ask me a question, you know, live or whatever, I'll feel free to ask anything. I answer any question I can about this or anything else Python related. I'll have the link for that below in the description as well. But thanks guys, take it easy.